digitalization, environmental benefits and costs. That's what we're going to focus on now. How will digital or smart solutions make the world more efficient on the one hand, but also do keep in mind, using IT infrastructure, computing takes up energy, and the more we compute, the more energy we need. What are the energy suckers? How do we handle that? And what are the chances that the energy needed to power all those computers is actually green? Again, I have three experts with me. Each one of them will do a little intro speech. After that, we discuss. And if you at home or you watching us here on this live stream, if you want to add your own questions to the discussion, you can do that by posting them on the Zero Emission website. Go to forum.zeroemission.group. Let's dive right into it. I'm very happy to have here with me on the panel Babak Falsafi. He is the founding director of the research center EcoCloud, founding president of SDEA, the Swiss Data Center Efficiency Association, and he is professor for computer science at EPFL. His field of expertise is, amongst others, data center architecture. In his intro speech, he will tell us about EcoCloud and how data centers can be made more efficient. Then I also welcome Xavier Verne. He is an engineer specialized in architecture for large IT projects. He is IT director for SNCF, the French transport company, but he is also a member of a think tank called the Shift Project, where they deal with lean ICT, or in other words, digital sobriety. And in his intro speech, he will talk about shifts, and he will be able to tell us to what extent digitalization hurts the climate. And last but not least, very welcome Antonin Guez, engineer by trade, and he is the CEO of ENGIE Switzerland, an energy company active in supplying its customers with energy, and they are considered to be one of the front runners in sustainable energy distribution. In regard of digitalization, he will be able to tell us in his intro speech what the smart innovations are that are coming up. Let's start with Xavier's key elements of reflection on lean ICT or digital sobriety. Please, Xavier.
Thank you. Do you hear me well?
Very well.
Thank you. So about digital sobriety, just as a few reminder. So it's you can see the slide is a presentation for the Shift project. If you don't know, I will not develop right here. Just a think tank in France that wants economy to shift to low carbon and under 2 degree scenario. About the 2 degree, let's sum it up. 2 figures to keep in mind. IT represents as a whole worldwide around 4% of all greenhouse gases emissions. Well, you could think it's small, 4%, but we do have a greater problem we need to tackle, because to make it to under 2 degree heating scenario, we need to decrease, as you can see here, by 5% each year, starting 2018, or by 10% if we wait until 2025 to be able to make it. So what it means is that IT and ICT, which is growing by 10% a year, will force other sectors to make a greater and a bigger effort, like, for example, agriculture and mobility. So we do have a problem, and we need, basically, I'm sorry to say that, but one COVID crisis, I mean, in the term of energy consumption every year, because the current estimation roughly says that with the COVID crisis worldwide, greenhouse gases emission would decrease about 4%, which is exactly what we need. So after this reminder, we can ask ourselves, on one side, as you can see, all smart projects like smart grids, smart buildings, smart city are opportunities for a low carbon economy. But on the other side, they do consume energy, especially for producing and for running, and lots of mineral resources and water and so on, which is as a whole and environmental costs. So the question is, how is it well balanced, and does do gains overwhelm costs, basically? About this, I'd like us to make a small thinking experiment. So let's say we are a renter. So you are a renter of a flat on the left, and for eating you each month you would pay 100 euros to get like 18 degrees in your flat. And one day your owner does invest into a new boiler, in the vault, which is more efficient. And after that, for 100 euros for months, you would be able to warm you up to 20 degrees, which is more comfortable. Or you would save 50 bucks and still get 18 degrees. So the question would be the following. What will you do? Well, basically the answer is the following. Most people tend to, to move the potentiometer and to turn the heating on, just to be able to be more comfortable. So this is exactly what is a direct rebound effect, because you reinvest immediately all efficiency gains into more consumations and more services for you. And you can have all situation in between. For example, you would warm you up to 19 degrees for like 75 bucks. And the rebound effect in IT is the following. This is like huge, and this was one of the first order of magnitude effect to be taken into account as we model things, because this is a global data sphere, as we say. So it's in zettabytes. So it tells basically that it's an ever-growing exponential curve, and that we do host and save more and more and more data, and that it costs lots of energy. Regarding, for example, hard disk capacity in your computer, it has doubled since the last 14 years, and since the 80s. It has doubled every year, so it's faster than Moore's law. And basically, what we are telling is that at the moment we state that our computer is still, almost full regarding its hard disk capacity, because of video that went from HD to full HD to 4K, and then we're talking about 8K, and the consumption on the device level is proportional to it's in the square of the resolution, so it's very important. And about infrastructure as well, to support all these new services and data exchange, we need to upgrade our infrastructures, like from 3G to 4G, and then we talk about 5G at the moment. And another way to say it, at the IoT level, IoT, as we say in the forecast of the next 10 years, will account up to 80% of all connected device ever growing market. So I'm not sure we want 70 billions around 2030 connected equipment, but this is rebound effect. We need it's getting cost efficient, so we do buy more to get more services. So I just want to say technology will not save us by itself, and for that we need. I often see two typical reactions. On the left, the innocent guy that would say, "This is not my fault. Providers have to be responsible for what they are selling me, and I don't have any responsibility." And at the other extreme, they are the guilty guy that would say, "I don't know. We are all lost because we are destroying the planet, and we need to do something." At the Shift project, we adopt an in between, maybe different approach, which could be co-responsibility. What it means if we need to change the way all our society is organized, and this is what we are talking about if we are to be serious about the carbon footprint as a whole, not only IT, but IT and mobility and agriculture and building and so on, then we need to be co-responsible. You need in your daily life, in your job, in your family, to play with all the levers you are responsible for in order to decrease our carbon footprint, or maybe to be more sober and to get some kind of common sense regarding all of this. And finally, I did put a few, one example that we're in the process of modeling precisely at the Chief project, which is one lamp plus one sensor plus one hub. And basically the lamp would just turn off when there's nobody, automatically when there's nobody in the room. So what we see on the left is that if you buy a LED, which is a quite already efficient lamp, it would take you up to like 100 years in order for this investment to be useful for the planet. I mean, to save you carbon regarding comparing the economy and the cost of building all of this. Of course, it is a small example, and if you instruments like 10 or 100 lamp, you still have gains. But and this would be my final word. I just warn you. Maybe I want to bring into relief that of this rebound effect. For example, in a city, if you get connectivity for your sensor with like Wi-Fi or so on, you will be tempted to instrument and to use this connectivity to make other things. Like, for example, once you have smart lighting, you want to have car parking optimization, and then you want to put cameras to put some surveillance. And then you have this rebound effect. And the risk is you will need, in the end, to upgrade your infrastructure, to put more sensors, to put more services. And we are back into the first problem I exposed to you. All right. Thank you.
Thank you so much, Xavier. Certainly going to be a big point in the discussion. How do people behave, and where does that behavior lead to? Let me just take, before I get the others going on their intro speech, one little question. You spoke about co-responsibility. How do you implement a feeling of co-responsibility in someone who doesn't have it?
So this is a big question. You're taking. We could take the color framework, which is the way people need to transform themselves and their behaviors. For example, in organizations, it often starts with an emergency feeling, because if you need to move, you need to move for some reason. So if we are serious on climate change, I think we first need to understand the link between energy and climate change, and of course fossil and other fuels. And then we need to be convinced we don't have so much time left to do something big. And then once you have this inner feeling of emergency, you can start acting, and then you would act rationally, and you would basically answer the following question: once I invest €1, how much lowering carbon footprint do I get in return? And this is what could help you, sort between I don't know, solar and smart grid and so on, return of an investment regarding these climate questions, for example.
Well, let's stay optimistic.
Of course.
Let's get to Anton Aguez, CEO of ENGIE Switzerland. Let's take it one step further. What innovations do you see coming up?
Yeah, thank you, Karen. First of all, let me thank Adrien and the Zero Emission Group for having me here. It's a great joy of being here, even though it's virtually. I would have loved being in Lausanne. And thank you, Karen, for hosting this. So I'll present ENGIE briefly, and then I'll build on what Xavier just said, and probably I'm going to use the rebound effect a little bit, but that's where the debate will come from. And obviously, when I come to data center, I'll speak under the control of Babak, who's certainly much more knowledgeable than I am on this topic. But to give you I'd like to give a little bit of industry perspective where we are. So first, ENGIE, it's a big utility. You mentioned it, Karen. 160,000 people working for ENGIE worldwide. If we zoom in, of those 160,000, 100,000 work in energy services. So that's construction of heating, ventilation system, electrical system, planning of plans, for instance, for our customers, and then 50,000 are roundabout in the energy world. And I'm saying this because it's just to give perspective on what I'm going to say later. In theory, so the group is doing three things, and I'm just flying through the slides to have more time for the debate. But we produce and distribute electricity, and energy, gas as well. Historically, that's our main business. And then we have so-called customer solutions where we operate district heating and cooling, we operate infrastructure, we help our customer being more energy efficient. So if we take those two businesses, the energy business, production, distribution, and the other one, which is more the construction industry, the building industry. On the first one, digitization, global digitization, what does it mean? It's obviously supporting the decentralization of the model. We're going from a very centralized model to decentralized model. So the impact on digitization for us is, as for any company, all the generic processes are going digital. That's probably the least interesting part for that panel. It's very challenging for an organization like ours, but it's the least interesting part for today. But then we have specific processes we could spend more time later on that are partially enabled by the Internet of Things and automation that Xavier touched on. So we could discuss about the trade-off. But it's the optimization of a lot of infrastructure with predictive maintenance, preventive maintenance of district and heating and cooling networks, as well as helping with the dimensioning of those. Because if you dimension it well, you don't build as much as you would have if you hadn't yet dimensioned it well. That's one. And the second is everything around energy management system to drive energy efficiency, identify, to be able to benchmark. That's traditional. I mean, people talk about it a lot, but it's something that is pretty difficult to put in place in reality. One other story that has been present for years in the energy industry, but that is made more pervasive in the energy landscape, is demand response, load management, which it's the process of adapting the consumption to the production. Historically, you adapt production to consumption. When you turn on the light bulb, you'll have energy, and so the energy producer produces enough energy to enable or to energize the light bulb. And now, if you have less energy on one side because you have no wind or no solar, then you need to adapt the energy consumption. And that's something that's enabled by digitization when we are trying to roll it out on a large scale. Last bit on digitization, again, I'm just throwing in some ideas, is everything around power purchase agreement. This acronym PPA stands for Power Purchase Agreement. With virtual power purchase agreement, when you enable a customer, and many data center customers are keen on having it, that you enable them to buy their energy virtually and making sure they have a green mix of power going into their assets. And that's partially enabled by blockchain providing the traceability of it all. So that's on the energy industry. The energy industry being very deep. If you see graph of digitization, you have a lot more industries coming before it. So the IT industry, obviously, but the energy is probably one of the industry that is the least digitized. But there's another one in which NG is active as well, which is not very digitized, and that's the building industry, the construction industry. As NG, we're very exposed to it. We build factories, buildings for our customers. And here, it's an industry where you have thousands of players, from small firms to large firms, engineering offices. So it's an extremely complex environment, and that makes it difficult to digitize. So here again, on energy efficiency, and Xavier mentioned the word IoT. When you talk about energy efficiency, the low-hanging fruits are mostly improvements on the existing infrastructure. And that's enabled by sensors, meters, or IoT devices. The long-term investments that provide energy efficiency, like isolation of a building, those take 20 years returns of investment, 30 years return on investment. So on the lower end of this return on investment scale, the low-hanging fruits, digitization is a key enabler. And on construction, BIM, if you've never heard that acronym, it's going to come to you in the industry, Building Information Modeling. That's basically having a digital twin of your building with more information in it. That's going to increase the construction phase of the building as well as the operational phase. So that's a lot of blah blah and probably maybe a bit abstract. So let me give you some examples, some further examples. Again, was mentioned in the slides of Xavier, smart cities, smart buildings. What do we do? As NG, you see on the some print screens of some of the digital models that we use. Basically, what we do is create a digital twin of the city, where you have all the information coming from the energy and usage world and merging with the infrastructure of the city, where you can evaluate, simulate the impact of measures you can do at the city level, going from LED lighting, temperature control, traffic management, waste management, water management as well, etc. We may talk about the enablers for it, but smart city, we have a big partnership with the city of Angers in France. We are going to invest hundreds of millions of euros to develop this smart city. This is an application that is being rolled out in other cities as well, where NG is a front runner. The idea again is really to create a digital twin. Now, digitization, the hidden infrastructure of the hidden champion of the digitization. So we build as NG data centers. People are not very aware of what it represents. Xavier just mentioned 4% of energy consumption, but it's a bit abstract and it's difficult to relate to it. When you have a big plant or a big infrastructure, you relate to it, it's a physical asset. And here, data center, in particular, colocation, it's a booming business, but nobody sees it because it's hidden. It's raising a lot of questions about integration within the local energy systems and the communities. Take an example in Amsterdam, they have banned construction of data centers because it was too heavy a burden on the infrastructure. There's a lot happening, but Babak will talk about it, about PUEs and energy efficiency, so I'm going to skip it. And with that, I think I'm done. Thank you. I'll be happy to answer questions. Sorry, it was very quick, but it was just to put some buzzwords in the discussion that we can come back to later today. Thank you.
Wonderful. Thank you so much, Antonin. Maybe just one question before we get to Babak for you. If you look at Switzerland, its infrastructure, where would you say at this stage are we at when it comes to having all the energy we're using for computing, the source energy we need? How green is it in the meantime? What would you say? Are we on track or are we lagging far behind? Just to give a quick impression that we can take on into the discussion.
I think Switzerland is doing pretty well. The great luck of Switzerland is, as when we're talking about energy or electricity, the electricity mix is mostly decarbonized, similarly to France. So when you put a data center in Switzerland, most of the electricity you'll be using will be decarbonized. So that's something good. There's the other aspects of the energy landscape or the energy industry. Well, Switzerland could do probably a bit more. We were talking this morning about hydrogen. That's one of the things that come to mind.
Thank you so much for the moment. And let's get to Babak. He will tell us about Echo Cloud. And you're the specialist on data center infrastructure. Please, Babak.
Hi. Okay. So, there we go. Okay. So thank you for inviting me. It's actually, it's good maybe that we're meeting online because I'm supposed to be in 2 different places today. So I'll make it only through online. So I'm going to talk about decarbonizing data centers. I'll talk about Echo Cloud and I'll also talk about SDA. So basically, I'm going to mostly focus on data centers. So we have to think about what data centers are. The demands and the trends are growing. We'll talk a slide about that, and then I'll talk about also the consumption of data centers and why is that an issue, and why do we have to build more, because historically we didn't have to. And so, well, here's just a graph that shows the growth trends. This is the data we just collected recently from Tecanovia. The storage has been growing according to conventional growth trends. Conventional trends have been exponential for the past 50 years, thanks to silicon, but also material that help us with storage. Data centers have been also tracking that growth. We're expected to grow at around 17% annually for the next 3-4 years. The economic sort of trends are hard to predict from the pandemic, but it's clear that with a transition of movement to IT, perhaps the IT trends will at least remain the same if they don't exceed our expectations. So there are two use trends that are giving a boost to a growth in data center market. One is the arrival of the edge clouds. Edge clouds are basically, historically, and at least when I started working in this business about 12 years ago, we used to have these gigantic data centers, the big ones. The big ones are actually, back then there were 30 megawatts. So those are, you can think of them as utility facilities. Nowadays, the big ones have grown to 250 megawatts. So they're really getting big. But now we'll also have data centers scattered around at more sites than we used to, as we're getting a bit decentralized because of IoT, because of the need to be closer to the source, because of the also need to be closer now with the 5G coming and data moving faster. You would also like to make faster decisions, and faster decision making means that you're going to be closer to the source. And of course, the decision making has to do with AI. So there's AI everywhere. IT, if you can think of AI as a slower version of cryptocurrency, cryptocurrency was a really fast, accelerated window of growth, mostly because the return on investment was really high. Obviously, carbon plays absolutely no role in that because it's not factored into the cost. But AI is a little bit like that. It's a slow motion version of cryptocurrency. So there's a lot of AI, and it's picking up, and some of it is also, just like cryptocurrency, redundant. All right, so why are data centers not getting denser? Well, it turns out that maybe nobody knew, but data centers actually were getting denser. Why were they getting denser? Because for 50 years, we could make silicon denser. And this is just pure physics. And as we doubled the density every 2 years, also the cost went down. So it's basically having almost free growth, exponential growth, which we took advantage of. And that's why we have IT everywhere today. Now, moving forward, we're getting to the quantum physics, where things that we're producing are getting too small. And so it's really hard to squeeze more space out of them. We're coming up with all sorts of interesting innovation for geometric shapes to allow these things to still squeeze some space out of. But for the most part, if you think of a conventional growth in density over 10 years as 20x, so for the same amount of space, same cost, you get 20 times better improvement, either in your service throughput or in storage. Now, in the past 10 years, it's slowed down. So to get that 20x back over 10 years, you need to maybe have 5 times as many racks as you had before. And this trend will continue because Moore's law basically is ending. Silicon's not getting denser. And so if you want any growth, you would have to basically, for the most part, build more. And data centers are, we talked about consumption. I guess there was a consumption graph on IT in general, and IoT specifically. This one is consumer devices. Here are basically portable devices. Manufacturing is the amount of emissions, electricity that goes into building equipment. This is only IT equipment. And then the data center network are the large parts, and that going to 2030, we're expecting to see a growth there as well. And this is just a sort of a exaggerated slide, if you will, that the worst case scenario for AI is really bad. So this is an article from MIT in the fall of 2019, where they showed that some of the latest AI models for which big companies in the US and also big companies in China are building equipment for are really bad. They're going towards cryptocurrency in terms of emissions. So this transformer model is one of them. One of the big ones is 5 times the lifetime emissions of 5 average cars in the US, which is pretty bad. This is an extreme case, but just want to make sure that we're all on the same page. Now, the association, we have a Swiss Data Center Efficiency Association. We launched it this semester. It just happened exactly in the same window when the pandemic was starting. We had a PR event at Davos, and the idea is that we're creating a label this year it's going to be the first carbon emissions label for data centers. It's a good time to have it because climate change also now is a more interesting question than it was certainly when I started looking at the environmental impact of data centers 10 years ago, 11 years ago at EPFL. And it's also comprehensive because it captures the entire end-to-end energy flow of data centers. And these are our partners. So I'll talk one slide on EcoCloud, which is our center at EPFL, but then we also partner with HPE. We partner with the Swiss Federal Office of Energy, with the School of Applied Sciences in Luzern, and then Green IT Switzerland, VigiSwiss, and Azut. And EcoCloud is a research center that we founded at EPFL in 2011, back when this was not an interesting topic, even though the data centers were growing at a phenomenal speed. Most of our affiliates actually did not really have carbon emissions in mind at the time. So we mostly focused on improving technologies to bring in the electrical ecosystem using renewables and also look at energy management within the data center together between the servers and the infrastructure, which would be cooling and electricity. We also looked at post-more server design to make designs more efficient. For example, the first server CPU that was built using ARM cores. ARM is a technology that's mostly in mobile platforms. The first one came out, it was blueprinted at EPFL, at EcoCloud, and there's a company called Cavium Networks, which is acquired by Marvell now, that built that first server CPU using ARM, 64-bit ARM cores that came out of our group. We've looked at integrated cooling and renewables, and we do a holistic approach to design, from algorithms all the way down to infrastructure, including cooling and electricity and storage and generation. And on that note, if you have any questions, please about the label, you can contact us at info@sta.ch. If you have questions about EcoCloud, you can contact me at EPFL at EcoCloud. Thank you.
Thanks a lot, Babak. Question to you. You were just showing all the things that are being done to make data centers more efficient. Are there figures to it? How much more efficient can you make a data center these days?
Well, there is, what's really important is that we bring in renewables, and we also handle heat recycling that comes out. Those are both factors that are captured in the label, besides making the infrastructure and the servers themselves more energy efficient. Is the topic that people have been working on for the past 12 years. And so I think that there are already many sites in Switzerland that do heat recycling. It's a little similar to the question of how clean is the energy. Well, Switzerland is probably at the forefront of the input in terms of cleanliness. But these are the goal is to bring these technologies in so that we can also then pass on those technologies for people who want to adopt, and then have a metric that will quantify how well you're doing.
Two small things. If I understood you correctly, then the big energy suckers at the moment, that's AI and that's cryptocurrencies, right?
Well, cryptocurrency is smaller in overall fraction of footprint, but it has a really interesting trend, which is it's extremely dense in using electricity, and also it basically throws away pretty much the large majority of whatever is actually used. So in that sense, the fact that carbon is not captured and somehow accounted for in that in the economics of it is a huge problem. AI is a much bigger, in terms of volume, it's a much bigger trend. It's not growing as fast as cryptocurrency in terms of electricity consumption. But AI is probably going to be a much larger fraction of the overall footprint of IT as compared to cryptocurrency.
Maybe a question to all the three of you. So as I understood, Moore's law is sort of coming to an end. There's going to be the need to build more data centers. And yet I've heard the people say, like, there's places they don't want them. Like I think it was Amsterdam. They said, no, we don't want any more data centers. Are we going towards a deadlock?
Well, I'm going to take the question on the infrastructure. You see, for a data center, we're talking about colocation, large data centers. Obviously, there are a lot of smaller data centers that are operated by users in other places of the world. But the large places, you need good electricity and good data connection. And the data connection, you don't get it everywhere. So you need, so there are hotspots where all the big collocators are locating. And one of them is Amsterdam, Düsseldorf, Frankfurt in Germany, or others. And in those places, and Vivek mentioned it, we move from 10 megawatts to 220 to 250. So when you have someone come with an energy need of, say, 100 megawatts, or it's building it over time, then the electrical grid is not always dimensioned for it. So suddenly you have the need to expand the grid capacity, put more transformers, more lines, more infrastructure. This is sucking energy from the rest of the economy, and so it creates acceptance issues.
So the issue is more the centralization, if I understand.
Yeah, I also agree. So there are three physical sources that are needed by the site, and networking and electricity are two of them. The other one is a source of water. I mean, cooling is still mostly based on water. So usually those three are taken into account when you try to think about building one of these big ones. I think that, there's no question that we will not be building everywhere, right? But the fact that there's plenty of places to build, that's the way to think about it. Now, the European Commission president announced just before the pandemic that Europe will be building more of these things. So European Union, if European Union can agree on data protection boundaries, and of course Switzerland then will join, maybe Norway, then we will figure out where to build. You will still grow, and it's a little bit like an electricity plant. I mean, you're going to think about where you're going to build these things. But if you find larger boundaries in which you can share these resources, then the growth will happen within, for example, the boundaries of European Union plus those in bilateral agreements with them. Right.
So the big topic that we also announced in the beginning is that we talk about this trade-off, that we talk about how much energy is actually consumed by all the IT activities, 5 to 7% at the moment. I heard So what if we talk about that trade-off? Now that we're in the middle of this corona crisis, people stay home, they do home office, a lot more is being needed. On the long run, can we actually say this is okay and it's still better than flying? Or how do you see that trade-off between actual physical traveling and all the things we did before and everything going online? How smart is really smart? Like how, or going digital or going smart, how smart is it really, to what extent?
Maybe I can start answering that. So Corona crisis is an opportunity. Of course, at the moment, it saves basically energy. I didn't make a computation or a fast calculation about that, but basically, if you remove all mobility, you are saving energy, even if you do like video conferencing and Zoom and so on. So at first sight, it's okay, and it's okay in a second way, because you do that essentially with the same infrastructure. And as Antonin said, when you set up a new data center, you need to suck more energy and you need to upgrade all the infra. Here, at the moment, Microsoft did upgrade a small of their infra to cope with all Teams and video conferencing and so on. But basically, we resist coronavirus with the help of all existing data center infra and nothing more. The risk for the next thing would be the following. That would be, okay, we did see that digitalization and IT as a whole is really a big help in this case of Corona trouble. And then we need to upgrade to 5G and to full HD and to Zoom++. And this is a story I've heard, because it looks like I'm the bad guy, the three people today, because I'm telling the story that we are entering a constrained world. So Babak said there's plenty of places to build data centers, and I would tend to promote the contrary. If we need to be serious about climate, there shouldn't be so much room left to build new data centers in the world, because we do need, but I'm sure we agree if we discuss more, because we need to enter in a constrained world where we think about absolute figures and not relative. So, and my last word would be a question for Antonin, maybe about la ville de Angers, about Angers. I would be very happy to get the computation that say, for Angers, if we upgrade and we put all IoT to resist to the next Corona crisis and to optimize everything, how much carbon does it save? Because this is a question. It's not if we do set up, we will be able to save more energy tomorrow. It is if I instrument all my city to optimize car and parking, how much do I save? For me, this is a question, because once again, we need to think in absolute figures, which is to degree and not relative future saves.
Yep.
Maybe we need to explain quickly, Antonin, Angers, that's one of the cities you were involved in making it a smart city, right?
Yes, well, so generally, I took the example of Angers, and I'll try to make a spoiler, but Xavier, I don't have the computation. I don't know if we take all in and all the scopes, how much the CO2 savings will be. I'll need
this
to
is
ask.
Complex, I understand.
But I don't have it here. But in general, what we tend to answer to your point, Karine, as well, is we try to take a systemic view at the entities, the campuses, the cities we take over to improve their carbon footprint. So another example will be campuses in the US. In the US, university campuses are enormous, much larger than what we have in Europe. So you can have several tens of thousands of people living on a campus. And so we signed 2 years ago 2 contracts with 2 universities. One is the University of Ohio, the other one of Iowa. And those are 50 years contract where we commit as a company, as Engie, to reduce the energy consumption of a campus overall, in absolute terms. That's in absolute terms. And it's there's a sharing mechanism so that the two bodies, the university on one hand and NG, have saving. It's an interesting view because, and I agree completely with Xavier that we are in a finite world. But in many cases, when you really want to make a difference, you need to take that long-term perspective. If I'm in charge of a building or of a campus, and those are enormous. Huh? I'm sorry, I'm going to detail on it, but to give you the sort of commitment, an idea of the commitment that we're making. So it's a 50 years contract. We commit to 25% CO2 reduction, energy consumption reduction, in the first 10 years. And the rest will be split about the other 40 years. And this is all financed on the books of NG. So those are the things we're trying to put in place. And the reason why it's so important to have a long-term perspective is because some of the measures you do will have an IRR, return on investment, that is longer than, say, 10 years or 15 years.
Yeah,
so if you
capital
don't
intensive, I understand.
You don't get the benefit. So anyway, so systemic view to take the overall landscape and to have a complete exhaustive analysis of the entity you're taking over, and then a long-term perspective as well.
But I mean, honestly, if we talk about those things, it was mentioned before, we need to talk about how do people actually behave. Somebody said it in the group. So basically, if they can have more, they will take more and they will want more. And you, Babak, mentioned it, or at least, you mentioned it. There needs to be a price, for instance, to carbon, or there need to be more regulations. Do I understand you correctly?
Yeah, so let me also talk to the point that was brought up about we need to just cut the overall capacity of IT or somehow limit it. The issue of IoT and personal devices and the issue of data centers are somewhat different. They're not quite the same thing. So data centers have to do with digital sovereignty, right? If we don't build them, or if the European Union and countries don't come together and decide where they should build them and what the capacity should be and what the regulation over it is going to be, we will forever be dependent on large IT companies like the ones in the US and perhaps even the ones that are in China now. These are the companies that are leading the way in technology and in AI, right? And you have seen already the impact of what this has had on democracies in the world, on privacy, on the future of the world is data. Data is a currency. So we need to have a global perspective. And at least within the European Union and the countries that are in such alliances, they should have a perspective towards how we're going to move forward, because digital economy is going to happen. And if we don't build the technology for it, we'll be dependent on other countries. And that's probably not something that the citizens want. Okay. So I would think about a limited capacity in a larger context, not on a per entity context. A company by itself cannot, or an individual cannot decide what that would mean for them, because this is for data centers. The idea of a data center is a centralization of infrastructure so they can host data and create services at a lower cost so that you're competitive. That is the fundamental reason behind creating data centers, right? And that's also one reason why they grow bigger. Now, what this means is that in the future, we need boundaries to regulate and figure out how to build these things and how to run. Now, with respect to the question about, how do we, carbon emissions? Carbon emissions we need to somehow bring that into the cost, right? If we don't, if we don't have some notion, I know, for example, Switzerland, has hydroelectricity, but I also know that Switzerland, trades that hydroelectricity for perhaps less cleaner electricity, because at the end of the day, it also comes down to markets, right? So we need to have some notion of carbon emissions for IT activity. At the end user level, if we're talking about change in behavior, yeah, it comes down to cat videos, right? I mean, there is an incentive for IT companies to create content that people then use to click on information and at the end of the day sell ads. And that marketing incentive there is problematic.
We're not hearing you, Karin.
Yes, we don't understand.
We're not hearing.
Yep, sorry. Microphone was off. They're mowing the lawn in the back of my. So no, I was wondering, I mean, what about the responsibility of IT companies themselves? I mean, do they feel like they need to do something? After all, they're making the big bucks right now, Amazon, etc. What is it like with them? Who takes on responsibility? And if it's not pressure from a government or somewhere, you know, how can pressure be put on?
So maybe about this question, just 2 words. First, I also tend to think that we need some kind of regulations. So in the legal part, we do have things to do in France and in Europe as well. So I tend to agree with always what's said by Antonin and Babak about carbon footprint of IT providers. We often see that at the moment Google and Amazon and other guys that are announcing lots of things. And Google did announce like 2 days ago, they were just optimizing their green energy, basically computing more when there is sun and computing less in the night when there is no so much sun. But just one thing to be warned about, because they are all talking about energy consumption during utilizations of the data center, and they are not, when they say they are 100% green, they often say that, and they are not talking about all the global footprint that was needed to make all the infrastructures. And once again, I would suggest to ask them to provide a full end-to-end cycle of this IT from cradle to grave, because we need to know how much did it take on resources and on carbon footprint issue to make all this data center to get a realistic figure.
Maybe at this point, I can weave in a question that came from the audience. And by the way, if you do want to pose questions, you can do that. The viewers on the Zero Emission Group website, that's forum.zeroemission.group. Right. Okay. I hope I said it right. And one question that came in goes sort of in that direction. It says, what about the impact of digitalization on resources such as rare earth materials used to build electronic devices? That's Marlene who'd like to know.
Maybe in 2 phrases, unless Babak or Antonin want to answer that. Just in 2 phrases. Yes. In a nutshell, at the Shift project, green IT people and lots of people are working on rare resources, like we talked about, titan and neodymium that are used in eolian and so on. To put in a nutshell, at the Shift project, we think that once you make your carbon lower, basically you use less fossil fuels, you are not able anymore to build all the consumer goods, and then the pressure on all these scarce resources is lowering. So we say climate first and resources just after, because they would decrease at the same time. But we can discuss about that. But this is the point of view we adopt. We deal with carbon first because the climate will be more hostile than titanium shortage in like 40 years.
Antonin?
No particular. I'm absolutely not a specialist on rare earth. There was a network session this morning on it with some specialist advice. So I'll just refer to it and to the replays that may be available. Clearly, it's an issue, but I'm not an expert of that question at all.
We've kind of moved away or moved towards production and what that takes on carbon footprint, but. maybe I can rephrase the question from before, Babak. How far are IT companies actually interested in taking on responsibility? Like you mentioned the thing with the cat videos, that they're interested in getting clicks, in selling advertisement, in making money, but are they also interested in saving the world or making it a sustainable place?
Well, I think that the big IT companies, I don't know anything about China, but the big IT companies in the US have a profile of what their at least inflow of electricity, what the source is. So I know Google, for example, they invested heavily in renewable energy upfront. Amazon's probably the ones that's trailing, that they're very little. And Google also had, at some point, a website where they showed the end-to-end carbon, including the manufacturing of their material. Based on the projections I presented, and I've seen, the manufacturing actually becomes a smaller overall fraction of carbon emission. That means that the operational emissions are going up dramatically. And if the Moore's law is slowly sort of dying, and once it really kicks into full gear, then you're going to see at some point a blossoming of more and data centers, and that actually has a direct impact on electricity. Because what happened with Moore's law was that your electrical activity per chip was also improving over the years. It's an exponential growth in capability at the same level of electrical activity. So yeah, I think that, there are no incentives in the US. And I think if anything, politically, we've gone the opposite direction. Europe is a forefront of this. The Green parties have moved into government in Germany a few years ago, this year in Austria and Switzerland. So we'll see a lot more around this in Europe. And we'll probably also see Europe being the sort of the pillar of technologies that are going to get eventually integrated into data centers.
Let me just say, Karin, to your point, as NG, we provide services such as power purchase agreements. We have signed, that's one of our big reference with Microsoft, the large one. So I don't want to speak for all the IT companies, but we see in certain cases that they want to secure green electricity. So that's the rebound effect that Xavier was mentioning. We are building more infrastructure to support the data centers. So we may question it, but when there is a new data center coming online, there is clearly a push by this industry to secure green power for their data centers. And de facto, we are seeing growth in the next year. So again, agreeing in broad schemes on what Xavier said, what we're living with is exponential growth of data centers. And in some cases, some of the providers want to secure green power. So what they're doing is putting money on the table to finance wind parks, solar parks, or whatever to power their data center.
You're off again.
Oh, sorry. Okay. Overall, if we're coming back to the question in the beginning again, this trade-off between moving more and more and more into a digitized world with all the impact it's going to have, and with all like the more energy it's going to use, is it still better than what we're doing today with actually moving, mobility, flying, and all?
I think it's great. I mean, the airline industry, I think when we started in 2011, airline industry was 2% of the emissions. I think by now it should be a little more. And I think a lot of that would move to online. And that's a good thing. That's not a bad thing. I don't see that. I think that's a good thing. And I think the emissions of that will come down. But then there will be gain in emissions in IT. But the emissions in IT relative to airlines when it comes to online meeting is a lot lower. So that's one of the positive things.
I think it's an extremely difficult thing to centrally rule on. I mean, and to say this is the trade-off, this is what you're going to do. And Babak mentioned it. We need to price in the externalities, and the CO2 is it's the Xavier mentioned the rebound effect. There's a this is the tragedy of CO2 is the tragedy of the commons, because you have something in common between every people is the fact that you can emit CO2 and nobody cares until to a certain point. And until we put a price on it, there's I think the mechanism in the society will not be aligned towards reducing that CO2 footprint, and you will be left with calling the shots between different industries in a way that is extremely difficult.
And maybe, 15:03, we do have a couple more minutes. See if there's any questions coming in still from the audience. But if you look at what Corona did now, that all of a sudden a lot of things were possible that were said are totally impossible. Be it employers saying, no, if people do 80% of home office, they're actually not going to work. They're just going to play around and fool around or whatever. And now we realize, hey, there's so much more possible than we actually thought was possible. That would be sort of the positive aspect of that COVID crisis. What do you think is the outcome of it? Is it actually that it gives, like, it creates new chances, for example, that belief in science gets bigger again, or that that they realize a lot of it can be done digitally. We can do a video conference instead of flying around the globe. Or is it going to be the other thing, that there's so many countries in despair that they'll say, we don't like digitalization. That's the last thing we worry about now. We have other problems at hand, and those need to be solved first. So sort of this thing that generally people forget about environment when they have the water up to here for other reasons. What is your personal point or view on that?
So maybe I would like to be very positive, because we all see that things are now possible that we would not believe that would be possible before the Corona crisis, regarding mobility and so on. But I would be quite pessimistic for the big shift you're talking about. For example, if you follow the news, you see that about flying companies and fly companies, as Babak talked about, that they are all asking the governments to lower taxes and so on, in order for them to come back exactly the way they were before the Corona crisis. So at the Shift Project, we tend to think, if you don't have a crash plan for this kind of crisis, when you are in an emergency situations, you want to redo things the way they were before, and you're not really ready to think about the whole thing and to start shifting our economy in a lower carbon one. So once again, it's possible, and we see lots of things, but we are not ready yet. So what we need to do now is to think about the next crisis. I'm sorry to tell that, but to have this kind of crash plan of the way we would shift people, for example, from flying to train companies, the next time we will get a big crisis like this. So
I think your question, Karine, is completely out of my room, my comfort zone.
That's why I'm asking.
It's very broad. I think, yes, we see that things are possible. Certainly it questions some of the assumptions we're building our society on. So home working is one. As the CEO of NG Switzerland, I will still be very careful. It's too early to say. It's a situation that is so unprecedented and unstable. When we say people are home working, in many cases, they're also taking care of their kids, which is an extremely difficult situation. Is it something that should last? What is the efficiency of it all? I still have my question marks. Also, I think it's food for thoughts that we're experiencing this reduction of the CO2 emissions, but we need to consider the costs of it. We're financing it with debt that are going to be serviced by the next generations. So it's a case study, and in many ways there are a lot of things we can take away from it. I'm rather on the optimistic side of things than on the pessimistic side of things, but we need to really take it with caution, because the risk is in such a crisis is that you use the crisis to justify everything you were already convinced of before the crisis. And I think this is a bias that we'll see happening, that we see happening already. So wait and see.
Wait and see, Babak, same opinion?
Yeah, I wanted to address a question you brought up earlier, which is how could companies help? I think companies, like I said, in Europe, more likely is where you would adopt, this label. For example, labels that we're coming up with is the first label that quantifies carbon emissions. You would then, you have companies in Europe that would quantify exactly what our carbon emissions is. If we get to the point where eventually we collectively decide that moving towards lower emissions is good for data centers, and I think there will be incentives also from the government to help stimulate the economy around that. I also see a question about bigger data centers versus smaller data centers, and
right, it's a question that's just coming from a listener or from
exactly.
a
So I'm also watching these questions, right?
And he says we do hear about the fact more decentralized small data centers are more sustainable than a few big ones, whether that's true or not.
So the idea of a data center is that you want to host data and you want to create services around that data, right? So there is, if you asked me 12 years ago, I would say, well, we only need the mega ones, and that's the best best you get out of centralization. Centralization gives you direct, not only it's good for economies of scale, but it also, the goal is that you collect data so you can then mine that data and improve services. That's the idea, right? Now, what's happening in the past few years is that it looks like you will also have this infrastructure closer to the sources of data, because there is this notion of fast decision making. There is some data that's coming in that's fresh, and you can already sort of use that information to then decide what you want to do and go back with a real-time constraint that will then be satisfied with proximity to the infrastructure. But that's the only thing we're going to see. It's not like everybody is going to build a little data center. It's the idea of building, tons of data centers is against the whole notion that you're centralizing this, A, because you want to make it more efficient and cheaper, and B, because you want to take advantage of the data they've collected. You can then actually improve service and create services, right? So no, I would say, it's not sustainable for everybody to have their own data centers, and you would still only see places where it makes sense to build data centers.
There's another idea that's coming on sustainability and how to create it. How about footprint labeling for online activities, so that you see on each and every cat video how big the carbon footprint is?
Yeah, so our label only stops at the data center, but I can see potentially labels that go beyond the data center. That's a very good point.
Keep in mind, I think it's important, because when we talk about the increasing use of data, I'm not a data center operator, so I'm not a specialist, but the fact is that when you build a data centers, generally, if you're a company, then you don't build one, but you build 2 to 3, because you want to have redundancy between your data centers. And when you have a mail or a video posted in the cloud, this video doesn't sit on one server somewhere. It sits on 2, 3, maybe more. So there was this exponential curve that Xavier was showing, but keep in mind that when we're building data centers, or when we're storing data in a data center, we're not storing it at one place, but in several places at the same time. There's replication going on to allow or to enable one benefit that all of us use and enjoy, which is that all your data is anywhere, everywhere, and at any time. And as long as we want to have that benefit, it's going to be difficult to change behaviors.
What we can do, Antonin did sum it up well. Sorry, about video. Video is up to like 60% of what's going. What is flowing into the cable. So first, if you optimize all the video flows, it would prevent us from upgrading so faster the infrastructure. So
Yep.
about the video, we have lots of things to do. Just for example, Zoom, when you are in small pictures, Zoom does not send to you the big high resolution flow to your device. So it's first use case, but we need to go beyond that kind of use case to save so much bandwidth.
Actually, all the online streaming services for movies ever since the pandemic started already did that because they couldn't sustain the bandwidth. So Netflix, Amazon Prime, they all went to lower resolution streaming just so they could sustain the bandwidth. But again, this goes along what you were saying, which is we need a notion of carbon footprint for this, not just throttle it for the service. Because at the end of the day, then we have a fixed price for the customer, and that price is only based on how much money we're going to make, not based on what the actual footprint of that is.
Gentlemen, thank you so much. Actually, we've only got 2 minutes left, and there's one final question that's come in that I would like to pose. Maybe each and every one of you can have just one short sentence to it. Somebody asked, well, what can educational institutions like the EPFL do? What influence can they have? Maybe the young people need to be taught differently, or what's going on? So what influence could a school like the EPFL have?
So obviously, on the research side, we've been pioneering in technology for energy efficiency since we started EcoCloud and even other activities at EPFL, the Energy Center, and beyond. On the education side, I think what we need to do is we need to do what the government of Italy did with climate change, bring it into K-12. We need to bring that again into the first year, right? And I think at EPFL, we have a global issues course that everybody has to take, but we probably need to sort of look at that and sort of keep making sure that this notion that there is there is an ethical issue, and then there is also things that a campus like EPFL can do in terms of making a difference in terms of technologies. Those need to be brought into the education, into the global issues course.
What are things maybe, Antonin, that the industry needs from an institution like the EPFL?
Excellent question. I think we need to be, the industry sits between, in particular, the energy and the construction industry, where ENGIE is mostly involved in. We're sitting on one hand, we have top engineers, top schools, we follow innovation. And then on the other hand, we have the reality of our markets, which are very conservative, slow to change, resistant to change. And so my biggest difficulty is not, obviously the research and development needs to continue, and the basic research needs to take place at universities. And that's the key role of universities like EPFL. But on the other hand, we need to find a way to shorten the time and to facilitate the time it takes between finding something and rolling it out. That's where, as the industry, that's the role of the industry, and that's somewhere where the industry struggles.
So basically, it's also about the human factor and trying to get people to comply and to actually move forward.
The biggest, in all of this, the biggest change, and you touched on it, and we didn't dwell too much, but it's the social and behavior factor. Where the energy transition is not something we're going to manage only through technology. I think the belief that technology will save us all is long gone, and it's really it can help, it can support, but we need to transform ourselves first.
I think we'll leave it exactly at that. Thank you so much, Xavier, Babak, and Antonin. And I will be picking up that human factor in the next panel, because then we're going to look a little bit closer into the construction sector, which you said it, Antonin, is really complex, where there's a lot of stakeholders and where there's a lot of conservatism. And I'll have the people on the next panel talk about how do you convince people actually, and what are the biggest hurdles. Just one spoiler, I heard the architects are quite difficult. So I'm going to explore that on the next panel. I thank you so much for being with me here today, and have a lovely rest. Thank you.
Thank you.
Thank you, Karin.
Well,
Merci beaucoup.